So, good morning guys, or good evening guys, whatever. So we have another problem from the following heats of combustion. So we have a series of chemical reactions. So this is what I'm talking about. This is more complex. Actually, this is a trial and error process. If you got to a more complicated problems like this one, you really have to try. And then of course, skill-based. The more you try, the more skills you can gain of doing this stuff. For the following heats of combustion, you have chemical reactions. Then calculate the enthalpy of formation of methanol, CH3OH, from its elements. So actually, you have to sum all these three reactions to have this final chemical reaction. So what you do is, you only have to find that CH3OH. And you can find it here. Waray na iba, diba? So meaning, it's safe that this one should be reversed, meaning that should be written as maybe I can try a red pen. So I will try to invert that one. Carbon dioxide, pananggalong ko lang mga notation, that is gas, and then you have your water, H2O, that is liquid, and then it will turn into CH3OH, that is a methanol, CH3OH, and then you have an oxygen, 3/2 of that. So since you have reverted it, the delta H of reaction, or the enthalpy of reaction, would also reverse, or meaning if it's an exothermic, now it should be an endothermic, 726.4 kilojoule per mole. Then the next is, we can see that graphite only appears. So this is not that complicated. Graphite appears at the left. So we can have graphite, C. You can see graphite. So this will just be copied. This is graphite. Carbon graphite. And then you have your oxygen as a reactant. Then it will form carbon dioxide. Carbon dioxide, delta H of reaction is an exothermic reaction. Delta H of reaction, standard, that would be a negative 393.5 kilojoule per mole. Okay? So, and then lastly, you have H2 and O2, which appears on the left. So, we only have to copy it. So, we have two, okay. H2 and we have H2 plus 1/2 of O2. We have CH3OH. Sorry. Where was I? H2 plus 1/2 O2. We have an H2O as a product. So delta H of reaction is that's an exothermic one. Delta H of reaction standard, that would be a negative 285.8 kilojoule per mole. So if we're going to sum this up, we can expect that your hydrogen, where's your hydrogen? This one has a multiple of 2H2. So actually, what you can do, because your hydrogen would be lacking, so you can actually multiply this by 2, since waray naman hydrogen nga mahatag mo dili igbaw. So meaning this should be multiplied by 2. Again, this is a trial and error process. I might take this long, okay, but anyway, it's up. That's good as it gets. This is a trial and error. So I'll multiply this by 2. So I'll multiply this by 2. I'll multiply this by 2. Okay? And then also the chemical reaction for this one will be multiplied by 2. Okay? So as you can see, you have already 2H2. But your oxygen now is, you have already 1 oxygen here. 2 divided by 2, that will be 1 oxygen. Oh. So you can see you have another oxygen here. So summing this up, you would have 2 oxygen. while the other side, your product has 3/2 of oxygen. So meaning 3/2 of oxygen. So that would be 2 so 2 which is bigger, this one, this guy over here. So this will be cancelled off because 2 minus 3 all over 2, that would give us 2 all over 4 all over 2. 4 all over 2 minus 3 all over 2. Okay, the 2 would be converted to 4 minus 4 over 2. 4 divided by 2 is 2. Okay, so that will give us 1/2, which is what we expect from the problem. You have a 1/2 of oxygen. So I guess this is already okay. This is already correct, meaning I can already sum this up. You have oxygen, and then this one oxygen will give us how much oxygen? 1/2. Yeah, we've already solved that one. 1/2 of O2. Okay, and then for carbon dioxide, you can see that it will be cancelled off. For water also, you have 2 water molecules here, and you have also 2 water molecules here. So the only thing that we did is just multiplying the last one into 2 and then inverting the first chemical reaction, and then we could already come up with the with what we want, which is C graphite, and then reacting with your oxygen, and then reacting with your 2 hydrogen molecule, and then the product would be a methanol. You can also see that if it is already correct, the chemical reaction would still be balanced. For example, you have 1 carbon here, we have 1 carbon there, you have 4 hydrogen atom, you have 3 plus 1, you have also 4 hydrogen atom from the product, and then the last one you have 1/2 oxygen. So you have 1/2 times 2, that would be 1 oxygen. So you have also 1 oxygen here. So it's already balanced, and the summation of the chemical reactions also already balanced. So therefore you can already add the chemical reactions. The delta H enthalpy of reaction standard would be equal to that 726.4, and then plus a negative 393.5, and then plus a negative, so that would be 2 times 285. 2 times 285.8, so that would give us 571.6, a negative 571.6. You of course units would be kilojoules per mole of everything, so I'll just omit the unit first, but take note we have units. So 726.4 minus 393.5 minus 571.6. So basically you have an exothermic reaction totally. That would be a negative 238.7. So it's an exothermic reaction, 238.7 kilojoule per mole. So that would be the enthalpy of reaction at standard state. At standard, or you can say standard enthalpy of reaction of carbon graphite and two molecules of hydrogen and 1/2 molecule of oxygen turning into a methanol. Okay, so and actually you can do this by experiment also. So that's how chemists or scientists knows for a certain, because they can check and recheck chemical reaction with many other means. Just like this one. Take this in connection with his lab summation, or probably a more basic one. That is chemical of reaction, or chemical of formation with energy, of course. So thank you guys for listening.